All right, we're just going to give it a few more minutes just to get the last minute attendees a chance to log in, and then we'll start the presentation. All right, I want to thank everyone for joining us today for one of our Thought Leader Series webinars. Today's presentation is going to be on precision agriculture, leveraging weather forecast data for informed crop management. I will be your host today. My name is Shannon Ryerson. I am a senior sales rep here at Olmstead. I have over 5 years experience with the company. I specialize in assisting researchers, consultants, government agencies, and universities in a wide range of environmental applications. Just a few housekeeping notes. This webinar will run for approximately 45 minutes. We will save 15 minutes at the end to answer any questions. You can type your questions into the questions section of the control pane. I also want to let everyone know that this webinar is being recorded, and you will receive a link to this recording via email once the webinar has finished up. So a little bit about Onset. We are the makers of the Hobo Data Loggers. Our facility is located in beautiful Cape Cod, Massachusetts in Bourne. We are our sole focus is on manufacturing data loggers that are reliable and highly efficient monitoring. We are a world leader in data loggers with a global network of distribution. We are ISO 9001-2015 certified, and we were founded in 1981. Today's presenter is Dan Olmstead. He has a Master's of Science from Cornell University. He specializes in decision support, digital outreach, and computer science. He's also a NEWA's project lead, and Dan manages over 1,000 weather stations, delivering data and tools for informed agricultural decisions. His work connects researchers to practice, helping stakeholders optimize pests, disease, and crop management with precision. And with that being said, I'm going to turn it over to Dan.
Great, thank you very much. I'm excited to be here. I think I did one of these a couple of years ago and it went very well. I'm always happy to collaborate on efforts such as this. So as was just mentioned, my name is Dan Olmstead. I'm a senior extension associate with New York State Integrated Pest Management. We're part of Cornell College of Agriculture and Life Sciences. And I'm project lead for NEWA, or the Network for Environment and Weather Applications, depending on where you're from. Some people say NEWA, some people say NEWA. It's okay, we all understand what you're trying to get across. Before I get into the details of my talk today and our discussion, I just want to point out that everything that I'm going to talk about today is done in really close collaboration with a lot of people, but in particular at Cornell, the Northeast Regional Climate Center. I'll talk a little bit about them, but I just want to give special recognition to Art DeGaetano, Bill Noon, and Keith Eggleston. So that's the director, and then support folks who really make things happen behind the scenes with data curation and all sorts of stuff like that. So let's get right into it. So today I'm going to talk a lot about risk forecasts, and precision agriculture. And what I want to start with is just a very high-level overview. My hope is that folks have heard of this idea of integrated pest management, but if not, I just want to provide a definition. So risk management strategies that reduce economic and environmental impact. And this definition comes from the IPM Institute of North America. And I just have their URL up there in case you're interested in learning more after we're done today. Like they said, this is being recorded, so you can certainly come back and visit that. So just keep this in mind as we have our discussion today. The next thing I want to do, if you have a smartphone or device, you can actually scan this QR code, or you can type in this URL I have. So I always encourage folks to play with the NEWA platform as I'm talking. You know, this is going to be available in different formats, and so don't feel like you've got to give 100% attention to the words that are literally on the screen. I think it's equally as useful to really be hands-on and playing with what I'm going to talk about in the next few slides. So If you go to newa.cornell.edu, you'll come to the landing page and you can just start poking around a little bit. The next thing I just want to explicitly point out is that while NEWA has a large geographic coverage, NEWA is actually part of a broader program at New York State Integrated Pest Management. We cover a lot of different areas. We do agriculture, we do community IPM, things like structural pest control. We really cover the gamut of public needs because we are part of New York's land-grant university. If you're not familiar with the land-grant system, maybe we've got some international folks. Every state in the US has a designated college or university. In some cases, there might be multiple. But the mission or vision of these universities is to deliver research-based information to the public. So New York has a lot of people, but at its core, we try to look at the high priority areas here at New York State Integrated Pest Management and really look at what research and extension is going on and bridge that gap. So NEWA is part of this effort, and we'll get more into this. I mentioned NRCC. There's actually 5 or 6 centers around the country. We're very lucky that the Northeast Regional Climate Center is also housed at Cornell. And again, NEWA has been around since 1996, and almost from the beginning, NRCC has been right there. There's a lot of data quality control, data curation. You can imagine with a lot of weather stations collecting hourly data, there's a lot of logistics that happens. And so just another key piece of information there. So when we talk about NEWA, really the backbone of NEWA are weather stations. And I have 3 different kinds up here. Obviously, we work closely with Onset as a vendor. On our end, we don't get financial compensation, but we want to provide an opportunity for high quality machinery that can reliably collect the type of weather data that we need to power the sorts of tools we'll be talking about in the next few minutes. But we also have a couple of other kinds of information which makes us unique. It's not strictly the vendor stations, it's also maybe state level or federal networks called mesonets. These are maybe definitely the highest of high-end equipment that you can get. There's dedicated teams of field staff, for example, in New York State that go around out of University of Albany, and they maintain 126 of these stations in New York, but there's also ones in Michigan and so on and so forth. The last bit of weather station background I'll provide is that we do also add airport locations or ICAO locations, and these are all curated through National Weather Service. So you can imagine that in our effort to provide highly specific, precise, and accurate information, we've got to blend all of these data types together to suit different needs. And we do this in partnership with Northeast Regional Climate Center. I just have a quick national view of our currently active locations in the NEWA network. And you'll see that we go all the way from Maine down south to Georgia and all the way out west, even to Idaho. I'll say a few things about what has spurred the growth of NEWA and why it's important, because this ties directly into what I'm talking about today regarding precision agriculture and risk assessment. So as I mentioned back in 1995 or 1996, we started with some very early weather stations. They held a whole maybe 10 KB of memory, and somebody would go out with their 20-pound laptop and download that data every single day. The idea was our apple growers really needed some tools to understand what's happening in real time. And so way back then, it was an Excel spreadsheet that somebody manually updated, and then over time, as technology advanced and web capabilities increased, we were able to get NEWA version 1.0, so to speak, on up and running through the web. And so probably by 2000 or so, and I'm sure there's folks on here who can remember more specifically than I can look back historically, we had coverage across New York State and the Finger Lakes, maybe in the Hudson Valley and up towards Lake Champlain. After that happened, from what I've been told, the apple growers across the lake in Vermont were like, well, why does New York have this? Why can't we have this? And that led to those first conversations about how we can make this more widely available. So from one point to the other, over time, states have slowly joined. It's been very, pardon the pun, organic in growth. We don't go out and recruit states, but what we do as part of our land grant mission is very helpful in other regions as well. And so we're able to do this thanks to our NEWA state coordinators who provide regional expertise and things like that. And at this point, we're in 26 US states. I think 23 of those have an actual person at a land grant university or grower association. And this is really what makes it happen. This is all about collaboration. So the data, the technology is important, but none of that would happen without the people behind it. And this is just a short list of some of the key players, and it's probably even expanded since I created this slide last winter, just to give you an idea of how NEWA is successful. So if you're already poking around online, there's a few things I want to point out about the platform itself. And again, this is just a quick orientation so that as we talk about risk assessment in precision agriculture, like how all these pieces tie together, one of the things we worked really hard on was to make NEWA agnostic in terms of who it is affiliated with. So the URL says cornell.edu, but if you're in Michigan and you're accessing a Michigan station, everything else is going to look like it's Michigan because that is who our partner is, and we want to make sure we're providing the right kind of support for those local growers. So you switch stations around or you're accessing it from a different part of the country, you're going to get a customized experience. A couple of quick just technical tips. These are the browsers that we recommend. You always want to have your most recent browser up to date. But these all work reasonably well, and we do our best to test this every winter. But if you ever did have problems, we do have a help desk that you can reach out to. You can send an email or you can access that through the NEWA website to get support. A few best practices for NEWA. Number one, use NEWA to supplement knowledge and expertise that's being shared by extension professionals and researchers or even consultants. We never want you to look at NEWA and say, well, it says to do this, so I'm going to do it. Because this is a best estimate. It's providing a prediction based on the most current research. I think you know best what's actually happening on the ground. And those professionals you work with locally are going to be able to provide additional context. And this ties right into practice number 2. So should always be part of a broader, well-informed integrated pest management strategy. We use the term tools in the IPM toolbox. NEWA, as interesting as it is, should just be one of those tools to help you make an informed decision. And then best practice number 3, reach out early if you're struggling to figure out the NEWA platform or any of our web app models. I talked a little bit about the data that happens behind the scenes. I'm not going to really go into detail on this slide, except to say there's a lot of well-structured support for the information that's being delivered on NEWA, regardless of where it's coming from. So if a weather station's down for a few hours, we have systems in place that will provide estimated data from national gridded data sets in the United States. And then when the actual data becomes available from your weather station, once the power's back up or once you've reestablished that cellular connection, everything is replaced. So we've got some really interesting workflows going on to make this happen. Now we're getting into, we'll get into more of how NEWA works and how we provide risk assessments. So I want to start with this list of available models and resources. And as you're looking through this list, what I want you to think of is, maybe you have your favorite weather app, or, maybe some of us still watch the 6 o'clock news. You get a 5-day weather forecast. And that's exactly what we're trying to do with these models. So with plant diseases, with insect pests, even certain crop management approaches, we can provide a 5-day forecast of what you might expect. And this is why NEWA works so well. I will say that a lot of our growth over the past 2 decades is due to interest in the apple and grape industries. Obviously, these are higher return on investment, but you also have greater potential for loss if it's not well managed. And in particular, the one I think of is fire blight. So fire blight in apples is a bacterial disease, and if you don't treat it quickly or manage it or mitigate the impacts, you can have severe economic loss in a very short amount of time. So if you don't have a tool like NEWA, or you aren't in close contact with your extension folks or your consultant, there's a really high risk that the investments you're making in your crops are not going to pay off, and you could actually see a significant economic loss. And we'll come back to fire blight in just a second. I have a screenshot of that in another couple slides. But before we do that, just a couple of other kind of platform level features is that it's a website, but it behaves like an app. Get a lot of questions about, well, why can't you just make NEWA an app? To be straightforward, apps like downloaded from the Android store or the Apple store are really high maintenance, because anytime there's an update to their operating system, you got to make sure nothing's broken. But what we've done is we take a web app approach. So if you go to NEWA on your phone, maybe some of you are doing that, you're going to get an app-like experience. So as long as you have that internet connection, you can use it, and sometimes you'll even forget that you're on a website. So we have a very responsive design that allows us to do this. So then the last thing I'll touch on here is an example of one of our models itself, and I'm just going to kind of walk you through what this looks like. So I mentioned fire blight before, and these are complex models, but what we've done is we work with researchers and extension folks to really capture the core of like what the published research says, or maybe there's other tools out there, and deliver in an efficient and clear way realistic assessments of what you might expect out in the field. So on a typical model, if you're on a desktop, for example, you're going to see on the left-hand side here all sorts of inputs. You can choose any of the stations that are linked to NEWA. This is an open access website. People who purchase a station privately do so with the acknowledgement that, you know, if their neighbor down the road might want to take a look, their data are accessible, but the data belongs to the growers. It does not belong to NEWA. It does not belong to IPM. It does not belong to Cornell University. We are just being stewards and using this in a way that is helpful to, you know, the general agricultural community. So you can choose whatever station you want. You can choose either to look at it in real time. And so if we were looking at this in real time and it was really June 7th, like the date of interest indicates, you would see little forecast tags under June 8th to June 12th on the right-hand side there. And that would indicate that forecasted weather data, both hourly and daily, is being pulled in to try and predict what those fire blight risk levels are going to be from these different types of models. And we've got some interactive stuff. You can hide and show these different elements on the right by toggling on the left there. A results table is pretty typical in what we've done on NEWA so far. And so in different ways, depending on the model you're trying to access, you're going to see a lot of visual delivery of information. And then depending on the model, you'll have access to more details. And I'm not going to go into this in great depth, but the last thing I'll point out is that if you do go to any of our risk models on NEWA, in the upper left-hand corner, you can always watch the tutorial. So that gives you a little more leisure time to kind of go through and become familiar with it. So before I move on, I just want to say the whole point and the reason that NEWA is successful is because we're starting to look at this in the past 10 to 15 years from a precision agriculture perspective. We want to know what's happening on farm versus what's happening 10 or 15 miles away at your local TV station or at your nearest National Weather Service location. So, sometimes people ask questions about the cost of weather stations, whether they're, a public resource or, being purchased from a vendor. We've done studies. We do studies every 5 to 7 years where we reach out with a survey to our NEWA users and ask them, what do you see in terms of impact, in terms of pesticide use, avoided crop losses, and things like that. And what we can reliably say is that, over the past 10 to 15 years, there's a consistent and very high response rate saying that I have reduced pesticide costs, and I have significant cost savings from avoided crop losses. Among apple growers in particular, these are probably larger, medium to large operations, maybe 50 to 100 acres on average, an average of $30,000 a year in avoided crop losses. So that's not insignificant. So you balance that with the upfront costs or maybe capitalized costs of, a weather station or, supporting some other program to get that on the ground data, and it definitely pays for itself. So that's kind of the first piece of this whole precision agriculture and weather forecasting approach that we use at NEWA that I want to talk about. I think what I want to do now is kind of start to expand our thought process around these concepts, though, because for a long time we've worked with agricultural audiences, but I think there's also opportunities. We've been learning this in the past few years that maybe we haven't been giving resources or providing support for similar efforts that might be on a smaller scale, but are maybe equally as important in urban areas and underserved communities. And so if you think about precision ag, you think about weather forecasts, we can talk about how these are important in these urban areas. And so the first example I want to give is a collaboration we have with a nonprofit called the Giving Grove. This is an organization based in Kansas City, Missouri. They're starting to work in other cities around the country, but what they do is they take fruit trees and nut trees, they go into urban communities, and they do revitalization. So they'll actually plant orchards, they'll work with somebody local, they'll provide training so that that person can be the orchardist, and they actually produce food for the community. And whatever is harvested, they distribute it at the end of each year. The interesting thing is, these might be smaller orchards, but they face the exact same issues as our rural neighbors. So you think about fire blight, you think about some of these other apple diseases like apple scab, they are struggling to manage the same things, and they have many fewer options. So if I'm a rural apple grower, I can make judicious pesticide sprays when I want to, but you're so much more limited in urban areas. And so this particular project, they've purchased weather stations, onset stations, and they are using the fire blight and apple scab models. They have a horticulturist on staff to make management decisions using whatever means they have available. So I wanted to point that out, and it's a slightly different perspective, but it's really interesting because I think there's a lot of folks out there where, again, what we're doing with NEWA in our more traditional audiences, we might be able to extend and start to talk about microclimate, especially in urban areas. Like there's so much variability. Like if you think about building structures and wind flow and rain shadows and all of that stuff, microclimate becomes critically important, and it's directly linked to precision ag, large scale or small. Coming to New York State, where I work, I have a couple of maps up here of our urban areas, and this really, all I want to do with these is emphasize that we have some very high population areas in urban centers, and a lot of these areas have food deserts. And so when we're talking about urban agriculture, we do have commercial operations. So in New York City, there's quite a few, and they're doing some really innovative stuff like rooftop farms. They're revitalizing vacant lots and all this stuff. But there are a lot of challenges. And so what can we do with technology and what we know about precision ag and microclimates to support this type of effort? Because we could have a really high impact if we're talking about extension efforts. Regardless of urban or rural, I wanted to put this slide in here because it shows, and it's just one example. I think this might vary a little bit depending on what data source you're looking at, but it shows how things have shifted even over a short period of time. So this was published in Fruit Grower News back in 2019, but they did a survey of apple farms between 2012 and 2017. And one of the interesting things, regardless of where you're coming from, is that the small farms are growing in proportion compared to some of the others. Whether this particular study looked at urban versus rural, not sure. But we do have an increasing number of growers, whether they're beginner farmers or maybe they've been in it a few years, or maybe they're veterans and just specializing. Who need support. But when you have a small farm, finding the resources to do what the large farms do becomes much harder. And that's really what I wanted to point out here. So to address that, and I won't go into great detail about this, but this is kind of like a branch or a parallel to NEWA, is that we are actually starting to look at what we've learned with NEWA. What can we also do for small growers? Maybe we don't need a large weather station. Maybe we can use smaller loggers that collect limited information, but that might still meet the needs of folks. So I wanted to basically just put this out here as an interesting thing to consider, that we have different uses for microclimate data and precision agriculture. And I did put this up here because I am working with Hobo using some of their smaller loggers. These are Bluetooth enabled versus using cellular telemetry or cellular data plans. So really our collaborators will go out, to an urban farm or an urban garden where these are deployed. They'll use their cell phone or their tablet device to manually load the data to their smart device, and then that automatically gets pushed to the cloud. And so the idea is to take that data and start asking the questions we've been asking on NEWA for the larger growers for a long time. The last piece I'm going to talk about, so we've talked about rural production, we've talked about urban production. I really want to basically just give you a visual and a couple of thoughts to consider after leaving today about why I'm talking about microclimate, even considering like maybe you have a base station that's more expensive. So this is, to be clear, this is not something on NEWA, but this is more on the research side. So this is looking at what's coming, looking at what we can do, and generating ideas for maybe a future tool on NEWA or something similar to it to provide support for our growers. What you're looking at is a custom platform that I've been developing for research purposes, but we're looking at data coming off of these onset systems. That green line is a traditional base station, and that's actually a station that's already linked to NEWA, even though we're not looking at a NEWA product here. But then the other lines you're looking at are remote sensors. So the name of this system that Onset has is HoboNet. But what you can do is you can deploy these remote sensors. I think, and folks can correct me if I'm wrong at Onset, it's like 1,500 feet line of sight, but they also talk to each other. So if something's blocking the path between a sensor and the base station, maybe somebody parked a tractor there, and I always call that tractor blight. The sensors say, well, okay, we need to get this data back to your base station, and they just figure it out themselves. But that's kind of a side tangent. What we're looking at here, so I have different remote sensors in addition to the base station. The remote sensors are deployed inside apple tree canopies. So what you see already is that these digital fingerprints are not identical. And these are from, they're on the same farm, but they're different management practices. So again, the green line, the station is out in an open area, maybe a couple 100 feet from any obstructions. There's nothing around it, it's just turf. The red line is maybe more of a traditional pruning practice, so maybe bigger, bushier apple trees with different types of airflow and stuff like that. And then that dark purple line, which admittedly might be a little hard to see, is a high density orchard, I believe. But really what I want to point out is the differences in temperature and the differences in relative humidity, because these are two important parameters that we use to make risk assessments in NEWA. So when you're looking at that 5-day forecast, you are looking at the culmination of what has been happening the past hours or the past days. Some diseases, you get relative humidity greater than 90%, and those risk assessment models are going to trigger a high risk warning, depending on what you're looking at. Or maybe it's the inverse, depending on how that disease physiology is. But the point is, we're looking at maybe a 1 to 2 week span. With temperature and insects in particular, if you have more heat accumulation inside your canopy or in a certain management practice versus that base station, how much faster are those insects going to develop? Or if we're looking at a disease, like if you have constantly higher humidity inside the apple canopy than what's being measured at your base station, which is perhaps more out in the open, it leads to a lot of questions. And this is probably a direction that we're going to be focusing a lot in the future. I know there's researchers here at Cornell. We're collaborating with computer science folks. We are starting to look at machine learning to come up with better predictions for these models. So I think what I really want to come away with here is that small differences over time could add up. And then, as you leave today, how does that impact what you're considering, like no matter where you are? So with that, I did put in live NEWA demo here, but I think in the interest of time, because we're already to 15 minutes left, I'm going to skip this and we can go right to questions. So that's my slide deck, but if you have comments or questions, I think the onset folks are going to organize those and we can just have a conversation. Thank you.
Thank you so much, Dan. So we actually haven't had any questions pop up yet. I am monitoring the question box, so anyone out there who does have any questions, please feel free to type in. With that being said, I didn't know if you maybe did want to jump into that NEWA demo, just to give our attendees a little bit more hands-on experience with it.
Of course. Didn't want to make
And
assumptions.
actually, Dan, we did have a couple questions up. They're coming in right now. So if you don't mind, I'm just going to read a couple of these off to you.
Yep, no problem.
Okay, the first question is from Lexi, and she asks, have you worked with corn growers and pests associated with corn?
We have. So let me get this up and I'll talk as I pull everything together. So I just want to verify, onset folks, you can see my browser?
Correct.
Okay, I didn't want to start without that. So what you can do, so if you go up here to IPM crop forecasts and go to field crops, you can see everything we have. And in particular, we have a Western bean cutworm model. And then in the next few years, we're working on a black cutworm model and a true armyworm model. So like I was saying, any of our resources have the same general layout, but what you'll find once you get there are, customizations and things like that. But if we choose, and I'm not sure where you are, but we'll just pick a location here in New York State. You can choose any location you want. The data is being queried, and then you've got this sort of output. Now, we're pretty late in the year for Western bean cutworm, but what it shows you is average temperature. It uses what's called a degree day model. Some folks might be familiar with that. But then what it really shows you is flight completion. So in this case, we put this model up because we had folks scouting. If you're a grower, if you don't have to worry about an insect emergence, you can devote those resources and labor to something else. I think that's a really big draw to some of our models. So Western bean cutworm is one. Another one we're working on is seed corn maggots. So if you're in New York State and you're in field crops, you know that I think in 2027, we're facing legislative restrictions on neonicotinoid seed treatments. And so what we are doing at New York State Integrated Pest Management is looking at the models that are currently available, saying, does this work in New York State? And then we're revising them. Because if we can, so one strategy you can implement as an IPM best practice is avoidance. So seed corn maggot comes out in the spring, at least that's what's in the literature. And then, if you avoid that period of time when adults are flying before putting your seed in the ground, you might be able to mitigate the potential damage. As an interesting side note, as you can see, we do have a seed corn maggot up here, but what we have in the literature, and we wouldn't have known this without modeling this in NEWA and following up, is that none of the models that are published are suitable for New York. What we're finding is that what we think is happening are adults or pupae rather are just kind of hanging out over the winter, and as soon as there's a couple of warm days, they're emerging. And so this is forcing us to reconsider how we're even thinking about modeling pest pressure. But this was a long answer to your question. The answer is yes. We definitely do corn risk assessments, and in the future, it's likely that you're going to see some more. What those are beyond what I mentioned, I'm not sure.
Great, thank you, Dan. I got questions from two other people that I think kind of tie into corn. So I'm going to read it as one question, but essentially it'll be a two-part.
Okay.
Part one is NEWA going to go to row crops? And then a follow-up to that would be, how do new diseases get added into NEWA?
Sure. Yeah, so row crops, I think up until probably 3 or 4 years ago, there was a lot of focus on fruit production. So like I said, apple and grapes. And the way we're structuring, there's still 100% support for those commodities or those industries. But what we're trying to do is expand our capacity. So we're looking for new funding. Department of Ag and Markets here in New York, and even DEC are interested in supporting more broadly the other industries across New York State. And so that naturally leads to additional support in other states as well. So the answer to row crops is yes. We're looking specifically at corn and soybean right now because we have this legislative deadline. And it sounds like there's going to be a process in New York where folks will use our tools. And if there's a high risk, there's the possibility of a waiver. Now, I'm not committing to anything here because there's a lot of things to work out. But what I'm trying to say is that we're using this sort of decision support platform to robustly support the industry, which is facing a big challenge. The second related question, can new models be added to NEWA? The short answer is yes. And so I'm going to kind of put on a project management hat and say that we really, for anything you see on here, we need some sort of expertise. And so as the project lead, I'm not going to say, well, I think Michigan needs this for their cherry producers. It works exactly the opposite. So I'm actually in discussions right now with Maya Tucho, who's our coordinator in Wisconsin. There's some interest in developing tools for their specialty fruit producers up there, and it's a matter of what's in the published literature. Is there somebody who can inform this risk assessment model as we're building it? Are there key stakeholders like growers who, right from day one before we code a single line would be like supporters and enthusiastic about providing the feedback we need? So it's definitely a process, but the answer is yes.
Great, thank you. We did have another question from Len, and if you don't mind, Dan, I'm going to go ahead and answer that. He asked, do you have a weather station data ingest API? Could you describe how it works? With the Hobo data loggers, our remote monitoring stations, they send their data up to our cloud-based platform HoboLink. We do have an API written for that. So if you did want to have the data sent from our platform over to a third-party platform, that is something that's doable. High-level overview here. If you want more information on that, Len, please reach out to sales@onsetcomp.com, and we'll be more than happy to assist you with that.
I'm going to add on to that as well. If you buy a weather station from Onset that has the NEWA configuration, you work directly with Onset, and then there's something called a data feed that you set up once you're in the HoboLink platform, and that's how you link with NEWA. And so Onset's done a really good job of configuring that, and we have support on our end as well. But we'll get you to the right person to link up that data regardless.
Yes, thank you for bringing that up, Dan. And we do, as just to reiterate, right within HoboLink, there is a data feed where if you're sending data to NEWA, you click on that, and it's a very seamless process to get your data from our equipment over to NEWA. And Dan, we haven't had any other additional questions. I would like to just give a few more minutes to see if anyone else would like to ask any questions.
Sure. Yeah, while we're doing that, I'll just pull up a couple of models that are really popular. So Cornell apple carbohydrate thinning model is highly useful in the spring. If you're an apple grower, you can use this to predict the carbohydrate balance in your apple trees. And so if there's a deficit, you take certain management actions, and if there's a surplus, you take different actions. And this really just helps you do those calculations. And so if we do this down here, let's see. This basically tells you when you should apply chemical thinners, when you should not. And you can see this gives you a prediction of what those carbohydrate loads are throughout the season. And then this is used to say, increase your thinning spray by X% or decrease or take no action and things like that. Some other useful tools, we have an all-weather data query. So if your Onset station is linked, so if we go to Geneva Agritech, Crittenden, this is an Onset station. You can choose your start date and your end date, and you're going to get data summaries. Okay. You can do hourly data summaries for the selected time period or daily summaries. You can go up to 365 days out. The other thing you're going to see in here, and this is actually an interesting case study, is so I talked about quality control. If the folks at NRCC, they've written routines, if they detect that a sensor is out, they'll provide estimated data, and that's what these yellow boxes are. But when you get that sensor fixed, so in this case, we have a leaf wetness sensor sitting in the office. We're going to go out, we'll replace that. Once that data starts flowing again, those yellow boxes go away. So that's the case for, I believe, airtime, precipitation, relative humidity, leaf wetness. I don't know, I can't remember if we do that for solar radiation or not, but just some interesting features. Looks like we've got maybe 2 minutes left. I could show you.
Yep. We did have another question that came up that I think may be helpful for the group here. Lexi had asked, is there a need for more weather data to increase accuracy of models?
That is a big question. So on a case by case, like what you always want is the most precise and accurate information possible. So farm scale is great. We want to move towards even microclimate measurements. So on like the consumption side of these models, like that's important. On the training side and on the research side, yes, the more data points the researchers can get, the better. We kind of get into a gray area with NEWA because we have really strict data privacy policies. So if researchers like want to make use of that, we need to reach out to individual station owners and get explicit permission. But you're exactly right. In the future, you might start seeing machine learning models. It's not as crazy as you might think it is, but the more data points and ground truth information that we have to train these, the more precise and accurate it's going to be when we're deploying these to something like the NEWA platform, or maybe it's another platform that's just as useful to you. So I don't know if that answers the question, but that's kind of my perspective on it.
Great. Well, thank you so much, Dan. There was a few more that came in. We'll make sure to reach out to you. As mentioned, we are recording this. We do save all questions. So any questions that we didn't get to, we will make sure to follow up with you. Dan, is there anything else you wanted to close out with today?
I don't think so. Just I'd like to thank everybody for having me, and I'll follow up on any individual questions as needed.
Great. Well, thank you so much, Dan, for taking the time to speak to us today. That was very informative. And thank you again to all our participants for joining the webinar today.
Thank you.